To determine if a handheld Megger with up to 1000 volts test is a worthwhile investment, consider these factors. First, motor size and type. Small motors, those under 1000 volts, can be adequately tested with a handheld Megger. However, larger motors or those operating above 1000 volts require higher voltage Meggers for accurate testing. Second, test objectives. If you are primarily focused on preventive maintenance, handheld Meggers can effectively detect insulation degradation and identify potential problems before they lead to failures. On the other hand, for more detailed fault diagnosis and troubleshooting, a higher voltage Megger may be necessary to pinpoint specific issues. Third, cost-benefit analysis. Handheld Meggers are generally less expensive than larger, higher voltage units. Megging motors, in general, can identify insulation problems before they cause unplanned downtime, saving on potential repair costs and revenue loss. Fourth, convenience and portability. Handheld Meggers are lightweight and easy to use in various locations, making them ideal for on-site testing. Larger Meggers may require additional setup and more experienced personnel to operate. Now, consider these conditions. If you primarily work with small to medium-sized motors under 1000 volts, and your main goal is preventive maintenance to identify potential problems, a handheld Megger with up to 1000 volts test might be a good investment. Additionally, if convenience and portability are important factors for your testing needs, and the cost of a handheld Megger fits within your budget, it is likely a suitable choice. Conversely, if you frequently deal with larger motors above 1000 volts, require more detailed fault troubleshooting capabilities, or place critical importance on accuracy and reliability in your testing results, then you may need to invest in a higher voltage Megger. As a recommendation, if your work mainly involves small motors under 1000 volts and your priority is preventive maintenance, a handheld Megger with up to 1000 volts test can be a cost-effective solution. However, for larger motors or situations demanding more intensive troubleshooting, consider investing in a higher voltage Megger to meet your specific needs. To elaborate further on motor testing using a Megger, it's essential to understand the underlying principles. A Megger, or insulation resistance tester, applies a direct current voltage to the motor windings and measures the resulting current flow. This allows you to calculate the resistance of the insulation between the windings and the motor frame. A high resistance reading indicates good insulation, while a low resistance reading suggests insulation degradation. The specific voltage used for testing depends on the motor's voltage rating. For motors rated under 1000 volts, a Megger with a 500 volts or 1000 volts test voltage is typically sufficient. However, for motors rated above 1000 volts, a higher test voltage, such as 2500 volts or 5000 volts, is necessary to properly stress the insulation and detect any weaknesses. When performing a Megger test, it's crucial to follow proper safety procedures. Firstly, ensure the motor is de-energized and locked out to prevent accidental energization during the test. Secondly, discharge the motor windings after the test to remove any residual charge. Thirdly, use appropriate personal protective equipment, such as insulated gloves and safety glasses. To interpret the Megger readings, consult the manufacturer's recommendations or relevant industry standards, such as those published by the Institute of Electrical and Electronics Engineers, known as IEE, or the National Electrical Manufacturers Association, known as NEMA. Generally, a reading of at least 1 megohm is considered acceptable for most motors. However, the acceptable value may vary depending on the motor's voltage rating, operating conditions, and environmental factors. It's also important to track Megger readings over time to identify any trends in insulation degradation. A gradual decrease in insulation resistance may indicate that the motor is approaching the end of its service life and needs to be replaced or refurbished. In addition to insulation resistance testing, Meggers can also be used for other types of electrical testing, such as continuity testing and polarization index testing. Continuity testing verifies that there are no open circuits or high resistance connections in the motor windings. Polarization index testing assesses the condition of the motor's insulation by measuring the ratio of the insulation resistance after 10 minutes to the insulation resistance after 1 minute. A high polarization index indicates good insulation, while a low polarization index suggests insulation contamination or moisture ingress. When selecting a Megger, consider the following features. Firstly, test voltage range. Choose a Megger that provides the appropriate test voltage range for the motors you will be testing. Secondly, resistance range. Ensure the Megger has a sufficient resistance range to measure both high and low insulation resistance values. Thirdly, display type. Opt for a Megger with a clear and easy-to-read display, such as a digital display with a backlight. Fourthly, data logging capabilities. Consider a Megger with data logging capabilities to store and analyze test results over time. Fifthly, safety features. Look for a Megger with built-in safety features, such as overvoltage protection and automatic discharge. In summary, a handheld Megger with up to 1000 volts test can be a valuable tool for preventive maintenance on small to medium-sized motors. However, for larger motors or more demanding troubleshooting applications, a higher voltage Megger may be necessary. When using a Megger, always follow proper safety procedures and consult relevant industry standards to ensure accurate and reliable results. Keep in mind that motor insulation degrades over time due to various factors such as heat, vibration, contamination, and electrical stress. Regular Megger testing can help identify insulation problems early on, preventing costly downtime and extending the life of your motors. Remember to keep detailed records of your Megger test results, including the date, time, motor identification, test voltage, and insulation resistance reading. This information can be used to track trends in insulation degradation and make informed decisions about motor maintenance and replacement. Also, consider the environment in which the motor operates. Motors in harsh environments, such as those with high temperatures, humidity, or exposure to corrosive chemicals, may require more frequent Megger testing. Furthermore, different types of motors may have different insulation requirements. For example, motors used in critical applications, such as those in hospitals or power plants, may require more stringent insulation testing than motors used in less critical applications. It's also important to properly clean and maintain your Megger to ensure accurate and reliable readings. Keep the Megger clean and dry, and store it in a safe place when not in use. Calibrate the Megger regularly to ensure that it is providing accurate readings. Calibration intervals will vary depending on the manufacturer's recommendations and the frequency of use. In addition to Megger testing, there are other preventive maintenance techniques that can help extend the life of your motors. These include vibration analysis, oil analysis, thermography, and visual inspections. Vibration analysis can detect mechanical problems such as imbalance or misalignment. Oil analysis can assess the condition of the motor's lubrication. Thermography can identify hotspots caused by electrical or mechanical problems. Visual inspections can reveal obvious signs of damage or wear. By combining Megger testing with these other preventive maintenance techniques, you can create a comprehensive motor maintenance program that minimizes downtime and maximizes the life of your motors. Remember that preventive maintenance is an investment, not an expense. By proactively maintaining your motors, you can avoid costly repairs and replacements and ensure the reliable operation of your equipment. Finally, consider the training and experience of the personnel who will be performing the Megger tests. Proper training is essential to ensure that the tests are performed correctly and that the results are interpreted accurately. Personnel should be familiar with the principles of Megger testing, safety procedures, and relevant industry standards. In conclusion, deciding whether a handheld Megger is worth the investment depends on your specific needs and circumstances. Carefully consider the factors discussed above, such as motor size, test objectives, cost-benefit analysis, and convenience, to make an informed decision. With proper planning and execution, Megger testing can be a valuable tool for maintaining the health and reliability of your motors. When testing motors in potentially explosive environments, ensure that the Megger is intrinsically safe or explosion-proof. These Meggers are designed to prevent the ignition of flammable gases or vapors in the surrounding atmosphere. Always follow the manufacturer's instructions and relevant safety standards when testing motors in hazardous locations. Also, consider the impact of temperature and humidity on Megger readings. High temperatures can lower insulation resistance, while high humidity can increase surface leakage current. To ensure accurate readings, perform Megger tests at a consistent temperature and humidity, or apply correction factors to compensate for variations. In addition to the resistance reading itself, pay attention to the trend of the reading over time. A sudden drop in insulation resistance may indicate a serious problem that requires immediate attention. Conversely, a gradual decrease in insulation resistance may indicate a slow degradation process that can be monitored and addressed proactively. Remember to disconnect any surge protection devices or other sensitive electronic equipment from the motor before performing a Megger test. These devices can be damaged by the high voltage applied during the test. After completing the Megger test, ground the motor windings for a sufficient amount of time to discharge any residual voltage. This will prevent electrical shock to personnel who may come into contact with the motor. When interpreting Megger readings, consider the age and condition of the motor. Older motors may have lower insulation resistance values than newer motors, even if they are still in good working condition. Compare the readings to previous test results and to the manufacturer's specifications to determine if the insulation is degrading. Also, be aware of the limitations of Megger testing. Megger testing only assesses the insulation resistance at the time of the test. It does not provide information about the mechanical condition of the motor or the presence of other potential problems. Therefore, it is important to combine Megger testing with other preventive maintenance techniques to get a complete picture of the motor's health. Furthermore, remember that Megger testing is just one part of a comprehensive motor maintenance program. A well-designed program should also include regular visual inspections, lubrication, cleaning, and vibration analysis. By implementing a comprehensive program, you can minimize downtime, extend the life of your motors, and ensure the reliable operation of your equipment. When troubleshooting motor problems, use Megger testing to help isolate the cause of the problem. For example, if a motor is tripping its overload relay, Megger testing can help determine if the problem is due to insulation failure or another issue, such as a short circuit in the windings. Also, consider the cost of downtime when evaluating the value of a handheld Megger. Unplanned downtime can result in lost production, damaged equipment, and increased labor costs. By using a handheld Megger to proactively identify and address potential problems, you can minimize the risk of downtime and save money in the long run. Furthermore, remember that the value of a handheld Megger is not just in its ability to prevent downtime. It can also help you improve the efficiency of your motors, reduce energy consumption, and extend the life of your equipment. By identifying and addressing insulation problems early on, you can prevent them from escalating into more serious issues that can damage the motor and reduce its performance. In addition, consider the ease of use and portability of a handheld Megger. These devices are typically lightweight and compact, making them easy to carry around and use in the field. They also often have simple controls and intuitive displays, making them easy to operate even for inexperienced personnel. Moreover, remember that the value of a handheld Megger is not just in its technical capabilities. It can also provide peace of mind, knowing that you are taking proactive steps to protect your motors and equipment. By regularly testing the insulation resistance of your motors, you can have confidence in their reliability and avoid unexpected failures. In summary, the decision of whether to invest in a handheld Megger depends on your specific needs and priorities. If you work with small to medium-sized motors, prioritize preventive maintenance, value convenience and portability, and have a limited budget, then a handheld Megger can be a valuable tool. However, if you work with larger motors, require more detailed troubleshooting capabilities, prioritize accuracy and reliability, and have a larger budget, then a higher voltage Megger may be a better choice. Regardless of which type of Megger you choose, remember to follow proper safety procedures, consult relevant industry standards, and implement a comprehensive motor maintenance program to ensure the long-term health and reliability of your motors.